Okay, welcome back, and let's do this problem now. So basically, let's read the problem statement. Water, initially a saturated liquid at 150 degrees Celsius, is contained within a piston cylinder assembly. So we always do a piston cylinder assembly here. Why is this important? Because this tells us that we are dealing with a closed system. Okay, and we know we have water. And then what do we know? It's initially saturated liquid, and we need the temperature, so maybe I will do here TV figure, TV diagram. So let's see, what do we know? This is T equal 150 degrees Celsius. So this is a constant pressure. And we know initially is saturated liquid. So initially we are over here. The water undergoes a process to the corresponding saturated vapor. So we go here. Okay? During which the piston moves freely in the cylinder. So that means that the pressure is constant. There is no heat transfer. So Q equals 0. If the change of state is brought about the action of a paddle wheel, so let's put a paddle wheel over here, determine the net work per unit mass in kilojoules per kilogram and the amount of entropy produced per unit mass in kilojoules kilogram. Okay, so basically we have a closed system, so applying the first principle of thermodynamics for a closed system, what do we have? Q minus work, and if we neglect potential and kinetic energy, this will be equal to the change in internal energy. Okay, so we know that Q is 0, so this means that the work will be equal to minus the change in internal energy. So we don't know the mass, so we know that this is equal to minus m U2 minus U1, or work per unit mass will be equal to minus U2 minus U1. So basically, in order to find the work, we need to find U2 and U1. So we are dealing with water, and we need to look at the table for saturated. So table for saturated I have here is table A4, and we're going to look at T equal 150 degrees Celsius. So what do we have? We need U1, we need U2, but at the same time I'm going to find S1 and S2. So we know that U1 will be equal to U liquid, or they use F over here, this will be F fluid, same thing over here, and this will be U gas, S gas. So if I go to the table over here, at 150, which is over here, UF is 631.66, UG is 2559.1, S fluid is 1.8418, and SG is 6.8371. Okay, so let me summarize this. This is U1 equal to 631.66. U2 will be equal to 2559 1. S1 is equal to 1.8418 and S2 is 6.8371. Okay. So basically, let me zoom out a little bit. So if we do the numerical substitution over here, we get that W over N will be equal to negative. U2 is 2559.1 minus 631.66. So this gives us that the work done will be equal to, so this will give you what? A positive value, this will give a negative value, to 1,927.44 kilojoules per kilogram, and this value is negative. So does it make sense that it's negative? If you remember, in the sign convention, work coming out of the system is positive, work going inside the system needs to be negative. So that's why we have a negative. That's the work done by the paddle wheel. Okay, and at the end we need to find what is the net change of entropy produced. So basically the only thing we have to do over here is what? Change in entropy is equal to what? Using the principle of the increase in entropy of the universe, we have the total change of entropy equal to the change of entropy of the system plus the change of entropy with the surrounding. So this is equal to m S2 minus S1 plus the delta Q over T. But in this problem, the delta Q is 0. So at the end, we can say that the change of entropy per unit mass will be equal to S2 minus S1. Okay, if we substitute, we're going to get that the change of entropy per unit mass will be equal to 6.8371 minus 1.8418, which is equal to 4.9953. So what's important over here is to realize that this is higher or equal than 0, which means that this is irreversible. Okay, so this will be the end of the video. Thank you for your attention.